Hi there. I'm John McPherson, and this is Jeffrey Schmidt. And Jeff has become, in what, 3 years you've been working on these bows, or 4?
Oh, 3 years now.
3 years. He has gotten to building Asiatic composite bows, and he's built one of, well, every major country that's built one: the Persians, the Turkish, the Chinese, the Koreans, Egyptians, and he's shooting, what, 8 now you have that are shootable?
8 shootable and 5 that are being built.
So what we're going to do is, first off, we're going to explain what a composite bow is and why we will make a composite bow. And that's what this little segment of talk is about. And from there, we're going to go step by step through the process of building a bow. And you're going to see this in less than 2 hours, to subtract minus this gab we got going here. But you have to realize that to build one of the finished, really good products that we're going to show you is like 5 or 6 months worth of work. And to the old Turks, they spent years, wasn't it 4 or 5 years they spent?
They could spend as much as a decade, but they would build the bows in batches of 500, and during one particular season they would just perform one operation, such as sinewing, on the entire batch. And then the bows would be seasoned out, sometimes in 2 or 3 periods. And it might take 10 years for a batch of 500 bows to be completed from raw materials to the stage where they're being sold.
What we're going to show you here is going to be like 5 months. Jeff's average time is 5 to 6 months. And we're going to compress it down. We have bows, and Jeff has prepared various stages of everything so that we can run through here in like 3 days we'll be shooting this. You'll see it in an hour and a half. But also you can build one within a month. We'll show you a quick way to build a composite bow. Well, let's talk bows first. Some of you don't have much for background possibly in the physics of archery or Boyers. And a bow is basically what most people think of is a piece of wood with a string tied at both ends that you bend, and you pull this string and throw an arrow, which is just another stick. Well, we've got some wooden pieces here to illustrate this with. This is a piece of hickory that's been worked down to the stage where it needs its final tillering to become a bow. And right now you'll notice that it is basically straight from one end to another. Well, when you bend this piece of wood, any piece of wood, when this is bent, don't bend it too far right now, but when she's bent, what happens is the outside of this wood is trying to tear apart. The inside is really just compressing, pushing together on itself, compression. These are the 2 major factors that control bows. A third, which is not really worth much or worried about much in wooden bows, a third principle is the center of the bow, which has nothing happening. It's called the neutral plane. In the bows we're building here, it has a lot to do. But on wooden bows, you don't worry much about that. But a piece of wood, when you bend this, eventually is going to blow apart if you bend it too far, regardless of the piece of wood. And most woods will fail under compression, the inside of the bend, before they will tear apart at the back. But either way, you have, what, 1%?
About a 1% strain in the wood. And what that means is that if you have a piece of wood, say 100 inches long, you can either stretch it or compress it by 1 inch, which is 1% of its total length, before it fails under the particular strain that you're giving it. If you are stretching it, a 100-inch piece of wood will break after it's been stretched to 101 inches. And so that's the limiting factor in bow design often, is making a bow that will bend to the proper draw length for your arrows and still be within some sort of safety margin for the materials.
So, when we finish this bow, and then I shoot it, I bend it, compressive forces are going to take over, and it is going to end up with what we call a set. It won't be straight anymore. It will be bent slightly towards the belly of the bow or towards the shooter.
This is the back side. This is the belly side down here, and the string would be running down along here.
So the bottom bow was straight when I began. It compressed. There's ways to counteract that somewhat, but for what we're talking, you don't need to know that. You can build your bow with what we call a reflex. Bend it backwards so that when you string this bow, you have it strung, you have more energy stored with a bow that is bent backwards than one that's bent forwards. One that has string follow or reflex. So ideally, if these were all the same bow, basically the same size configuration in woods and same poundage bows, let's say 50 pounds, the one that would shoot hardest and furthest would be the one before stringing that had the most reflex. And the one that had the most deflex or string follow would not be as efficient as these other two. Now, as Jeff mentioned, wood has, now this top bow here, it's reflex, you see this fuzzy stuff, that is sinew, it's been sinew backed. We're going to talk about this in our composite bows. Well, let's go back to our basic plain bow. 1%, you can stress this. In other words, we could stretch it or compress it 1%. That doesn't give us much. It makes good bows. They've shot for years and years, the English longbows and Native Americans and all around the world. Most cultures used wooden bows. They still are today, and they work really, really efficiently. But you can only stress this to a certain extent. You can only bend it so far. So if I wanted to really reflex this bow to get the most out of it, a piece of wood, what if I reflexed it way back, like 8 or 9 inches? Backwards. It would probably break before I got the string on it.
Because just in getting it to the point where it's straightened out, you would be straining the wood on the belly side and the back side by your 1%, and the bow will probably not take any more than that. So it'll break before you even get it to this point, trying to put a string on it.
So you can get a really fantastic bow out of just a piece of wood. This bow here is a 100-pound bow. I can't draw it completely. That's with a 23-inch arrow. And it has thrown, what, a 260 grain arrow, is that one you sent me? Mm-hmm. It's thrown a flight arrow that Jeff sent me over 300 yards. We lost it as it went into treetops at about 15 or 20 feet in the air, and it was 320 yards. So this thing can throw an arrow a considerable distance.
And that would be a tremendous shot for an English longbow, by the way. This
is 48 inches long. Now, let's improve on this bow. First thing we're going to do is we're going to take some horn. This is horn of a gemsbok. Comes from Africa. It's been sawn in two. This is horn of a buffalo, a Native American bison, and this would work for making the bow. And this is horn from what, Asian water buffalo?
This is a strip of Asian water buffalo horn, the inside curve.
This is what Jeff builds most of his bows from. This we use on the underside of the bow, the belly, the side that faces the archer when you draw it, that is under compression. Because this has 4 times, 5 times the compressor of wood.
About. This can take an overall strain of 4%, which means that the bow can be reflexed before being strung, and it can be drawn farther after being strung, roughly 4 times the curvature of a limb of a wooden bow, and still fall safely within the limits of the material.
But if you bend this, it's going to break before it goes any great distance, because it doesn't have tension. It won't stretch. even as well as wood, will it?
No, it will not. The trick is to make sure that the horn, which can withstand compression, is placed on the bow in such a place that it will have to withstand only compression and not tension.
So this by itself isn't going to make much of a bow because you are backed as if you had a piece of wood. With the exception you would be able to bend it further if the back didn't go apart. So what we're going to do is we're going to take sinew, tendon from animals, and this is off the back strap of a deer, and we're going to shred this out into threads. And we're going to glue this on the back of the bow. Let me grab a strip of horn. This is just exactly the one I put down. It has been shaped, and we'll show you this later, by heat, moist heat, and it's been flattened. So this is one limb of a bow, this is another limb of a bow, and all we need to do is place sinew on the back side with a reflex and get a reflex. This is simple composite bow. Jeff's got one here he's going to show you.
This is the type of reflex that you end up with. This is an extreme case. The bow looks a little bit out of balance right now, but when it's strung up, the limbs are balanced extremely well. This bow was nearly straight before it was sinewed and reflexed, and the shrinkage of the sinew alone has pulled it into this shape. Now, as you can see, you're going to have to exert an enormous amount of force and put a lot of energy into the bow just to straighten out the limbs. And that's energy that will be stored in this bow above and beyond what could have been stored in a straight limb bow. Then, in addition to that, this bow, being nevertheless quite short along the curve, can be bent tremendously far and shoot a very long arrow because the materials are so extremely flexible compared to wood. It can take an overall 4 times or 5 times as great a curvature as a normal wooden bow. Now, this bow would probably not be efficient if it were not reflexed because the horn and the sinew are both denser than wood. So this bow, as it stands, is heavier. It weighs more physically than a bow made out of wood of exactly the same shape.
That slows a bow down. When you make a bow, the material you make it out of automatically slows down its operation. So you want lightest material you can, or you use what physics you can to make it as efficient as possible. So by placing in that bow that Jeff just held up, 2 weeks, 3 weeks?
This one was sinewed 2 weeks ago.
And he's had it strung. And we're going to string it again later. You'll see it later in the video. Hopefully we'll get to that point if we don't run out of time. But this will be bent. If you took a piece of wood like this, you'd never even get it straight. It would explode. It wouldn't make it. Horn on the belly, sinew on the back. The sinew stretches 5 times maybe the amount of wood. The horn compresses that much, and so you can do fantastic stuff. You will show you here. This is what, Turkish?
This one is Indian.
Indian
subcontinent.
A bow. This is reflexed. This is backwards from what it will be when it's strung. And you couldn't take a piece of wood that is in this shape and do anything without it exploding. It would just blow up on you. I'm going to put this down just a moment and grab this because there's one concept on the other bow which we'll cover in a second. This is just the tip where the string will be placed. This is the other tip, but it's going to be bent backwards. If we did this out of wood, there's no way we could do anything. Right. This bow, compared to this bow, have almost identical shapes up to this point. These are what we refer to as ears or sayas. What they are is cheaters. Like when you have a wrench and you're trying to pull and it doesn't work, you put a bar over the end of it and you pull it, makes it easier to move it. That's what these are.
Their purpose is to allow you to apply more leverage to the limb. In effect, it acts to lengthen the limb after the string has lifted up off of this portion when you're drawing the bow back. And then for the second half of the draw, you get the benefits of having a long limb bow. In addition, the geometry of having this sharp bend allows you to keep the angle that the string makes with the end of the bow always small. That makes certain that as you draw the bow back, it doesn't stack on you. And stacking just means that as you draw the bow farther and farther back, the amount of force needed to gain an additional inch of draw begins to go up dramatically. Suppose you've drawn the bow 28 inches, it may take another 10 pounds to pull it back to 29, then it may take another 20 pounds to pull it back to 30. Now with a bow that has this feature, it's much smoother. Once you've drawn the bow back to 28 inches, it may take an additional 5 pounds to pull it back to 29, maybe an additional 2 pounds to pull it back to 30, because these begin to act more and more like levers to load compression into the belly of the bow as the bow is drawn back farther. Unfortunately, it adds a tremendous amount of complication to the process of making the bow. This bow took 6 months to make. This one that John built took how long?
2 weeks.
2 weeks to build.
Now it's been curing out for a lot longer, but to build it, it took nothing at all. We'll get into the building process here in a moment. We want you to understand what's happening. So this, let's say, is a 70-pound bow, or 80 pounds. Let's say 70. That's about what I can actually handle. So let's say I can draw a 30-inch arrow in this bow at 70 pounds. Well, if I put sayas or ears on the end, that just makes it easier for me to pull that 70 pounds. It makes it seem like 50 pounds possibly.
It's like putting bars or pipes over the ends of the bow and allowing you to pull it back with much more leverage.
So I can pull it as far, but it's easier for me to pull it. But in the process, we're adding weight, more mass, to the very end of the bow, so that slows it down. And so it won't shoot like this one will, is a 70-pound bow. If I put sayas on this now to help me draw it, it would shoot maybe more like what, 60 pounds?
60-pound bow. It'll be more comfortable to shoot, a lot more comfortable.
Yeah, much better. But now we can get rid of some of this. We can take this bow, which Jeff built, and instead of being 70 pounds, if I can handle 70 pounds, this could be maybe 90 or 100 pounds. Because the addition of these sayas, or ears, makes it easier for me to pull this and shoot it.
It's the problem that you have with discomfort is due to the stacking of the bow. And it also makes your shooting very erratic because as you tire out, suppose each time you draw the bow, you draw it maybe a fifth of an inch less than you had the previous time you fired. Then, since the stacking is so tremendous at the end of the draw length for an average bow, a typical bow without these features on it, your shooting is going to be very erratic because you may be drawing at 29 inches at 80 pounds, then you draw at 27 and a quarter and it's only 75 pounds or less. So your shooting could become very erratic. This feature will make the bow much smoother to shoot. A remarkably heavy bow will seem very comfortable to fire. The one that we have completed down here, for you to look at, is a Turkish style bow, Mameluke bow, and it draws about 100 pounds at 27 inches. It certainly does not seem that heavy when you actually draw the bow. It seems much lighter, but when it's been weighed, it comes up to about 100 pounds at 28 inches, 27, 28 inches.
They're two different style bows, the same concept, but you'll notice the sayas or ears are shorter on this one. And but you can see the amount of energy or force that's stored in this bow before it's drawn.
Now this one will look like this when it's strung, except of course these ears will be longer. And as you can see, it's not a trivial matter to get a string on something like this.
There's special boards and methods of doing this.
In Indian mythology, the Indian god Shiva was killed when the saya of his bow split his skull after a rodent chewed the bowstring. So a certain amount of care must be taken in getting the strings on these bows. It's a good idea to have two people doing it and some special tools.
We'll get into this later. This segment we want you to understand why we're making a composite bow, the advantages. I think you can see from our wooden, straight piece of wood, what we've done is we've utilized horn on one side, sinew on another side, in which is not visible in here. We have a piece of wood down the center, we'll show you in a second, that everything is glued to. That one short bow that's put up here, that has no wooden core. This is just sinew glued to the horn. You can make this faster, there's less work, but it's not as efficient. Jeff says as he strung this, it was like fighting a wildcat. The wood, besides acting just as a gluing surface, also acts as some stability, it appears.
See, the horn wants to compress as it's being drawn back, and the sinew would like to stretch. And if the two are being played off against one another, as you string up an all-horn, all-sinew bow, the entire horn layer will begin to compress, and the entire bow will physically shorten. Now, that's not going to be true on a bow like this. The median plane in this bow, the wooden strip that runs through this bow, will not compress. This is about the shape and thickness of the wooden strip that goes into the bow. This will retain its length as the bow is loaded and strung. Now, on the other hand, if you take a sinew bow with a horn belly and no wooden strip, the core of the bow is the horn, and the whole thing will compress quite a bit as you string it up. And the result is that the bow seems to be unstable. You'll have a large curvature in one limb that will migrate to the other limb and back and forth again. The bow will want to shed its string, and the result is that you have to get this bow strung up with some special tools, let it sit around to equilibrate for a while before you try to take the tools off and shoot it.
Okay. Jeff, why don't you go through real quick you got your core, your finished piece, your ears that you have. We're going to be squeezed showing how to build it if we don't get going.
All right, this is the wooden core. This is made out of a strip of maple wood, hardwood maple. Actually, it was a board, a 4x4, about 8 feet long, sawn in half, and
lift it up a little bit.
Okay. I have an unviolated growth ring on the back of this bow, and this is something that a technique that I got from John. It is probably not necessary to do in a sinew back bow, but John feels that it's a wise thing to do, and I feel likewise that you should try to get the back of the bow an unviolated growth ring. So what I had done was targeted a flat growth ring in the board. Then all the material above it was shaved off with a spoke shave and with a plane. And then that growth ring and the one directly underneath it were sawn out of the board, and it was trimmed up. What you have at that point is, say, a 1 1/4 inch wide, 3/16 of an inch thick board. It's about 4 feet long. Then I had cut it to length and steam bent the ends using some tourniquets and some bending forms and gently steaming these pieces. And so you end up with a core which will form the neutral plane and the gluing foundation of the bow. The next step is to obtain some pieces of naturally curved wood or splice together some ears. And these are ears made out of ash. They had begun as naturally curved pieces of wood. This was actually a bend in the tree limb itself that had been sawed out and split in order to make two pieces of identical curvature and grain flow. Now these will be spliced with fishtail joints into the end of the bow like this, and you can see why that recurve is put in there. It follows the curvature of the ear extremely well, and it gives you about a 45, or in this case, almost 90-degree bend in the limb at the end. You can see that the line that runs through the ear in this direction is very nearly perpendicular to the plane of the flat belly of the bow. And so this will give you a piece of a core that's already partially reflexed. Now after that's been glued in with a fishtail joint, it will look roughly like this. And you'll have a piece that looks like this. Now later on, a reverse riser handle will be glued onto the back of the bow. And I generally do this later on so that it doesn't interfere with operations in the meanwhile. But the next stage in the operation, after inserting the ears and gluing them in place, is to put the horn belly on. And so we have some horn strips over here. These were corkscrew twisted up, and they've been steamed and flattened with heat until they are These are about 27 inches long, a little bit longer than necessary. You could probably get away with pieces 16 inches long. Now what we will do with these is cut grooves in them. Longitudinal grooves will be cut down the length about 10 or 12 to the inch. There'll be triangular grooves, and then mating grooves will be cut into this piece of wood, and the two pieces will be carefully fitted together, and then they will be glued in place to form the belly of the bow. And once this has been done, we have a bow here that's at that stage. This is the completed core with the horn strips on the belly. This is probably close to a ½ inch thick, but it's going to be shaved down now on both sides until it's about, say, 5/16, and then about 1/8 of an inch or more of sinew will be added on the back of the bow, which is this surface. And when we're finished with that, this little space will be filled in. As the sinew dries and contracts, the bow is going to bend around until the limbs cross. And in so doing, this space is going to open up maybe 1/10 of a millimeter or so, which is why I generally don't fill it in until later on in the construction. But that's filled in with a piece of any hard material, hardwood, ivory, antler, horn, bone, whatever you'd like to put in there, even a metal piece if necessary. But this is the basic construction of the bow. Again, fishtail joint to hold the ear in, groove the back of the horn strip and the belly of the wood strip and glue them together with a great deal of pressure. We generally bind these in place with a cinching bar and a rope. That's allowed to cure out for about a week, maybe 2 weeks, and then the bow will be sinew backed all the way up to here, along the entire back, up onto the ear, and thickly over the handle. And when we're finished, what we'll end up with is a bow that will look a lot like this one. And you can see the sinew completely covers the entire back of the bow. It goes well up onto the ear. In this case, it goes all the way nearly to the tip of the scia. This scia was made with a splice here and a splice into the limb there, Indian style, has a double bend. Then the section in the middle between the two horns is filled, and you essentially now have a bow that you could go out, cut nocks into, brace, put a string on, study the curvature of, and perform natural tillering on.
Well, let me real quick point out a couple things. One, you notice Jeff's been handling stuff on the right side. I've been handling stuff on the left side. That's because grease that's on your fingers or any place, you know, these wooden bows I handle have got grease on them, will contaminate. The glues that we're using to put this stuff together, which under all this tremendous force wants to just blow apart, if you have any grease in there contacting this wood, if these wooden pieces Jeff was handling, if he had any grease at all contact, he'd have to start all over because you would not get the bond necessary between the two. So you'll find as we get into the construction, very, very, very careful. We'll be washing and cleaning every step of the way.
And resurfacing wooden surfaces between every operation. Immediately prior to sinew backing this core, we're going to scrape it down again with a razor blade to expose fresh grain, open up fresh pores, and eliminate any grease that may have been accumulated from our hands or from settling out of the air. You have to be extremely careful about this. We'll say it over and over again, but this is a good reason for bows failing. Contamination with grease. It's got to be avoided.
Okay, Jeff explained how he's going to build this composite bow we're illustrating here, and it's normally like a 5-month job. This is the quickie, and it could be made bigger or smaller, and the one that I made was made a lot quicker because we didn't cut grooves and we didn't put in scias or sayas, whatever, tomatoes and tomatoes. So you can build one quickly. But now that we've got this one here illustrated with this, I want to show you real quick a benefit and a de-benefit or unbenefit of the composite bow. This is a composite bow. It's got a wooden core. It's got 7 pieces of antler on the belly. They're compressing so you can have them just butt up and meet each other. And the back is sinew. So it is a composite bow, but it doesn't shoot as well as a wooden bow with the same weight, because there's more mass to this bow. This bow weighs more. You put it in water, it's going to sink where a wooden bow would float. This is going to shoot less well than a wooden bow, everything else being equal, because when this was built, wasn't built with a reflex. It was just thrown together. Jeff built this, what, 2 years ago, 3 years ago?
First one.
And he just slapped it together, and it's straight. Well, we can bend this tremendously.
Yeah, it
You
can
know,
take
it's
an
like a
enormous
huge,
strain.
huge rubber band. But the problem is, I don't know of anybody whose arms are long enough to take full advantage of all the stresses that you can apply to this. It should have been built with a reflex.
This little bow can easily shoot a 30-inch arrow if you can pull it that far. And it certainly is in no danger of failing, even though it was very crudely put together, very crudely glued. It was glued by heating it over a kitchen stove, in fact. But it's made all the wrong way. It's straight, it has no reflex. Now this bow that John is building is a virtually identical design. However, it has a tremendous reflex in it, and it's probably going to outshoot this bow hands down.
Of course it will. Okay, I think hopefully you've got a concept of why and what of a composite bow. Now we're going to put Jeff to work, and we'll put them together so that you can see how to do it. Jeff, what are we up to?
Well, I'm trimming up a piece of wood. It's got a real nice natural curvature to it in the grain. It's a chunk of Osage. It's got a real beautiful flow of grain. It's a gorgeous piece of wood. Curvature is pretty big. This is going to become 2 ears, or probably 4 ears for 2 bows. It's the section that we've been calling the Sia. What I'm doing is trying to trim up the edges so that they're square. So I have a piece that's going to be easy to split. My plan is to split it this way so I can get 2 batches of ears out, and then to split along here and to utilize this section in here, this highly curved section, to make the ears of the bow. And I'm doing it in such a way that the edges of the growth rings are going to be exposed, so we're going to get a really beautiful piece, real nice piece of wood, real nice coloration, nice grain flow for the ear. And trimming it up with this, you can use an axe, you can use a cleaver like this, a machete, anything you're comfortable with working with. This has a nice heft to it, it's easy to control. It's a very hard piece of wood. That's what I'm up to. Okay, this is where we're at. The split gave me a piece, real flat. Should be easy enough to split. My plan is to split along here like this, so that I get 2 sections that I can use for ears of identical curvature. So I'm going to need to split it along here. So what I'm going to do is again use hand tools, but I'm going to put a couple of cuts in here to kind of guide things along. I'm going to put a cut here. I'm going to put a cut here. We try to put a little one in there, and hopefully the split will follow those cuts because there'll be lines of weakness.
What you got, buddy?
2 ears. Perfect. Okay, you can see the growth rings on this stave. What we're going to do is split this along the growth rings. You can see how nice and flat they are. This is the sort of thing that you want, flat growth rings. You can see down the length when you were able to look at it before that they're nice and parallel, nice and straight. And this is a piece of black locust. John already split a stave off of one side, this side, and he used it to make himself a composite bow. And we're going to get greedy and try to get 2 more staves out of this by splitting it. Now the split might not follow the growth rings perfectly, it might go in and out a little bit. But we don't really care about that because if we goof up, we're still going to get at least one stave out of this. So that's the plan. Try to split this lengthwise along the growth rings.
Now you see, we're going to try to split this exactly in half. And you can see there's a large tree, so we have flat growth rings, which will make great for retaining one growth ring for the entire length. Yes, he seems to be starting pretty easy. We'll just see what happens.
Okay, the splitting wasn't exactly successful, but we got one fine board out of this with a little bit of natural reflex in it. It's got a slight propeller twist, which we could get out by twisting it in the other direction after steaming once we thin it down to the right thickness. But this is really the sort of thing we're after, a stave like this that can be worked down with a plane or a draw knife or a scraper, spoke shave, whatever you want to work it down with. You can run it through your milling machine if you want to. But this is the sort of thing that you're after. A nice stave, flat growth rings, flat surface for gluing the sinew onto, about 4 feet long, 1.5 inches wide to start out with. You eventually narrow it down to whatever you want. And now you begin to work this thing down to a final thickness of about 3/16 to a final absolute thickness of 1/8 of an inch after it's been glued to the horn. But you target about 3/16 just to keep a little bit of extra thickness on there so that you have more to work with as you take the thing down into final shape.
Okay, Jeff, now we've seen the raw materials for the ears, the core. We'll cover sinew and glue in a bit as we go. But one of the biggest things we're going to be concerned about here is horn. Why don't you tell us? I see you got a piece of buffalo horn there. Explain something here, what we're doing.
Yeah, this piece really illustrates exactly what you want optimally as far as horn is concerned for making a bow like this. This is a horn that's relatively short, but it does not have any twist in it. And that's the most important feature, no twist. Now this surface is the outside curve, and this is the inside curve. This has been taken out so it can be used as a spoon. But it's the outside curve that's going to be probably the best piece of horn because it's the longest. It's slightly concave on its inner surface, and that's good. And it has the right curvature to be placed on the belly of the bow. It wouldn't have to be inverted to be placed on the belly.
Why don't you pick up that piece of water buffalo horn to show a comparison in size, because that's what we're working with inside.
Okay, on the other hand, this is a strip of Asian water buffalo. This is the inside curve. This would have gone along the surface of the horn like this. You can see it's much larger, a little blacker, a little finer grained, much more expensive, and it has a little bit of a propeller twist to it. So a piece like this would have to be flattened, straightened out, and that twist would have to be taken out of it.
Now how are we going to do this?
Steam. Boil it, steam it.
Moist heat.
Moist heat is important. Yeah.
But you say that also you've cautioned me on overboiling it and weakening it.
Yeah, you don't want to overcook these things. They will burn, and if you get them soaked with water, it may crack when it dries on you. So the idea is not to overcook it. Just steam it or boil it for a few minutes to make it plastic, and then bend it. If you need to straighten out a piece like this, if you'd like to get that propeller twist out, you steam the middle section, and then you grab it in your hands like this and you twist in the opposite direction. You see now it's twisted
right.
propeller, now it's straight. And then once it's been heated up and you do this, you dip it in cold water in the middle, and that will set the curvature. That'll cool it down fast, and it'll stay in the new position.
Well, my experience with working with horn and antler both was it didn't take very much time at all. Like you said, just minutes.
A couple minutes.
And I know that when I worked with that antler bow, that I probably overdid it with 15 or 20 minutes. I could almost tie knots in it.
Yeah, antler is a slightly different material, slightly tougher to work with. It's a little more brittle. And if you overcook antler, it's shot, because antler consists of a bony core, bony matrix, and a protein content that's inside of the little cavities in the matrix. And if you boil that for too long, you're going to cook the protein, denature the protein, leach it right out, and you're going to be left with something that's not going to be as flexible as if you had
barely cooked it or steamed it only slightly. And again, it's minutes. It only takes a few minutes to get this into a plastic state. So don't overdo it.
Well, let's stay on the horn then. But we might just well let everybody know that, you know, antler works, elk antler, even deer antler, I'm sure would work in short segments.
I've heard of American Indians making bows out of all those materials.
And then ribs, bones.
Bones, yeah. There's a lawyer in Slovenia, a young man, has made a couple of bows with horse ribs for belly.
Same thing, compression.
Sure.
Okay, well, let's stay with the horn. We're going to run out of time on this tape. But horn and antler, let everybody know, is a viable substitute. But let's work with the horn.
Okay.
And you've got those Kemsbach horn.
Yeah, this is imported by knife makers and knife makers' warehouses into this country. And it's used to make handles. It's a long, straight horn. It's an antelope horn. Very plastic, very long grained, readily available. There are dozens of companies in the country that import this stuff. And the nice thing about it is that there's very little waste involved in using one of these to make a bow. You can split it lengthwise and then steam it very gently and clamp this surface, the bottom surface, to a flat metal plate and apply C-clamps to the other side and flatten these out almost completely. And you look at that curvature and you think that it doesn't sound very likely that you'd be able to do that, but in fact it's a lot easier than it sounds. And this is the result. These are some that I had worked down that way, and they are very nearly perfectly flat. Now you might notice, if you look at these closely, or if you do this at home, you might find that some very small cracks are going to open up on the belly. Well, these aren't very important. They're going to fill in with glue. They are longitudinal cracks. The bow will not have any stress in that direction, so it's not going to hurt things at all. So you should keep in mind that this is a nice source of material for you to use. Of course, you can go to any leather shop and buy a pair of cow horns, and as long as they're not twisted up, you saw out that outside curve in the cow horn, and that's probably the most readily available material that we have in this country for making bows like this.
Now you're using, like on everything else, you just use a handsaw, hacksaw, for just about everything.
Handsaw if you like. You can use any tool that you like to cut this out, but I always prefer to do things by hand because you have more control. You go slower, but again, you're going to be spending months making a bow like this, so why rush? What I would do is just mark on here the piece that I'd like to remove. Make it a little bit wider on the horn than what you really want, because you never know, you might want that extra width later on. And I take off that outside curve, like this. And now what I would do is clamp this into a workbench somewhere. You might need to touch this up a little bit, make sure that you're taking out nice parallel cuts on opposing sides of the horn. Clamp this into a workbench and start cutting at either end. I usually start cutting at this end because the horn is solid here, and I don't like to be tired out and working on tough material at the end of the sawing, so I start at the thick end. I would cut the tip off and start sawing in this way and follow the grain, go very slowly, and eventually you're going to get to this point and you're not going to be able to saw any further, so you take that blade out of the saw, you turn it at right angles so that you can saw this way, down the length of the horn. Go nice and slow, make nice even cuts, take your time, and you won't find this very difficult. If it's a long horn, it might take you a few hours, but so what? I mean, if you're going to build a bow like this, presumably you're willing to spend the time on it to begin with to do it right.
Sinew. A lot of people may not even know what sinew is. Simply put, it's tendon off of animals, but why don't you show us some?
Okay. You've got some hunter friends. They can supply you with plenty of raw materials if they know how to take it off of the animal. This is backstrap sinew from deer. 2 of these will come off of a deer, and it'll take about a dozen or so of these to completely back a bow with 3 or 4 courses. This is very easy to prepare. It's extremely easy to shred. You just get yourself a tendon, flatten it out, and tear it apart. Then you can pull individual threads off of this And you can shred these as fine as you like by hand, or you can use a simple men's pocket comb, use the coarse side to just rip these fibers right out. But be careful you don't tear too many up that way. Now you can also go ahead and use leg tendon, Achilles tendon from deer. This needs to be pounded. It's a lot of bother. This is the best stuff to use, probably. Easiest to prepare, maybe the easiest to get.
Well, I know Jeff uses a lot of leg sinew. I just don't bother with it because I have an unlimited supply of backstrap sinew, and there's a much less work involved in working with that.
Much simpler to prepare. Leg tendon, you can obtain cattle leg tendon from a slaughterhouse, practically for free. You hammer it on a stump with a sledgehammer, comb out the fibers. It's much shorter. The fibers generally will be maybe 4 to 6 inches long.
Mm-hmm.
And you hammer it on a stump, comb out the fibers. They're fatter, they're greasier, but they're free. Very easy to get from any small slaughtering operation of cattle.
Glue. We're using strictly hide glue here, which is boiled down animal parts.
Right. This glue is made out of hides, rawhide in particular, rawhide scrapings. It's produced in the United States. It's produced all over the world from byproducts of tanning operations and slaughtering operations. It's sometimes made out of rabbit skin, but the general form that you buy it in is granulated like this.
All hide glues are extremely strong. What is it? The weakest is 3,200 psi.
About 2,000 pounds per square inch.
That's bone glue, though, right?
Well, that's marketed often as hide glue as well. And hide glue comes in many different grades, but almost all grades are sufficiently strong to make one of these bows, unless you're trying to make a very short, very highly reflex bow. I think you can get away with using practically any hide glue. You can use the rabbit skin glue that's sold in art stores to size canvases. You can obtain it in practically any art supply store in this country.
Well, I know it.
Canvas size.
We've got a lot of it through people working with stained glass.
Right. It's used in stained glass because as it dries, it will shrink, and if you smear it on stained glass, when it dries, it shrinks and pulls the glass up in spalls. This is very easy to obtain in a large number of art supply stores, various arts.
Well, our friend Tim Baker, he's said Knox Gelatin Works. That's basically what it is.
Sure. Head down to the grocery store and buy yourself some Knox Gelatin. Gelatin is simply very highly refined glue that is bacteriologically free or sterile. It's free of impurities. It's edible. This is edible, for that matter. Now, hide glues are all extremely strong, as John has said. Practically any one of them can be used to make a bow. There are higher grades.
Okay, I see lots of granulations in your hand. This is generally what we find.
Yes, it's mostly sold in this form, or a finer powder, or pearl form.
Right. And you have also a sheet.
Well, this is homemade glue. This is made from fish bladders, which were bought at a Chinese grocery store or Chinese pharmacy. And then these bladders were softened up by soaking in water. They were ground into a pulp, and then they were cooked for about 4 hours, and the glue extracted from that. This glue is about 1.5 times as strong as the hide glue I'm holding in my hand, but it is more viscous. It needs to be watered down more before it will penetrate into wood. It was used in Asia because it's flexible.
And you can make your own glue. You've made a lot of glue, which is simply boiling down, what, pieces of hide and sinew?
Yeah, you can take a piece of rawhide and reduce it to shavings, soak it in water, cook it, or you can use the fish bladders, or you can use sinew scraps, again, degreased, soaked in water, and cooked. And then you strain off the liquid and condense the liquid. The liquid is the glue itself.
And now preparation, now when you're getting ready to utilize this, why don't you tell us a little about that?
This needs to be reconstituted. Both of these types of glue will absorb 6 to 10 times their own weight in water. So to prepare granulated or dried glue, you add water to it, and it will swell as it absorbs the water and form what's called a reversible gel.
then it has to be heated up in order to liquefy it and prepare it for use.
Yeah, and that takes,
Few hours.
well, when I've sinewed bows, I've learned from you a lot about, soaking it in cold water. I've just before gone strictly to the hot water, but in 30 minutes I'm ready to go. But it's constant stirring.
Yeah, this will not require any stirring if you just simply soak it.
Okay, that's a pretty good background on that.
Both the cuts turned out really very well. You can see that the cuts are very nearly vertical with the center plane of the piece. There's a little ledge here that we have to grind off with sandpaper. The cuts are nice, they're straight. Should be a good splice. Nice and simple, took about 20 minutes. I've done a couple dozen of these, and every once in a while you ruin one. So you go slow and just expect that now and again it's not going to work out. But what I'm doing now is grinding off any peaks, making certain I have a flat gluing surface. I'm refinishing the wood, which opens up lots of pores for the glue. Trying to make that surface perfectly flat so I get a glue line in the joint that's a couple thousandths of an inch thick. And again, the secret here is there are no secrets, you just go slow. And every once in a while you expect to ruin a piece. And every time you make that cut, it doesn't necessarily turn out right the first time. It's taken me quite a few to get the procedure down. These are the two pieces that we're proposing to join. This is the core, and this is the ear that we just cut out. And we're going to join it right here. So I've bent the piece of wood that forms the core into a curve that fits the ear by using this device that I found to be the easiest way to get a nice straight bend in the wood. It consists of a wooden block that has precisely the same curvature as the ear, and this is clamped onto the core with a C-clamp and a little piece of wood to protect the core. Then we have a tourniquet and a little bar and a rope, a loop, and this loop goes around the bar and is tightened down with the tourniquet while the wood is going to be steamed. The steaming softens up the wood to the point that it becomes plastic and can be bent and will conform to the bent shape after the heat's removed. I found that this is the best way to do things rather than just using a lot of clamps, because clamps get red hot when they're steamed. So we get this into the pot. We have a few inches of water in the pot. We get the whole thing ready to go. We put it in, cover it up, and let it steam for a couple of minutes with the tourniquet placed on very loosely to begin with, so the wood is not stressed before it's been heated. Then after the steam's been acting on it for a few minutes, we take it out, tighten the tourniquet down halfway, put it back in, steam it for a few minutes till it heats up, take it back out, and tighten the tourniquet down all the way. Then we let it in the steam for about 5 minutes or so, and take it out and let it cool naturally in the air. Then when the form is removed, the end of the limb will have this nice bend in it. The ends will be nearly straight. The biggest bend will be in the center where the form had the biggest dip in it, the largest curvature. This particular way of doing things gets rid of a lot of C-clamps which are hard to turn down. It's more primitive. You could do it under very primitive conditions. It's more adjustable. If the limb is starting to twist, this bar can be repositioned very easily. Slide it up, slide it down to the end. The whole system is very easy to operate, very easy to use. It's very sensitive, and to give you a very precise curvature bend. What we're going to do is mark out the cut that has to be made into the core to receive the ear. This is a single fishtail splice. It's about 3.5 to 4 inches long. It's at the very end of the limb, so we center the ear so that the line that runs down the middle of the ear would continue to become the center line of the bow. And then we just mark out with pencil the line that we want to cut along. And then we cut within that line slightly to get just a little extra material on each side in case we goof.
That's close.
Yeah, that is a very close joint. This is probably one of the best ones I've had recently.
All right, but you've got a little spot there.
Right here, you can see a high spot. If I could grind that out, it'd be even closer on that side. We could get the wedge in farther.
All right.
This side is absolutely perfect. There's just no improving it. It's just as perfect as could be. See, this is how good you can do just going slowly with the simplest hand tools. Electrical tools, power tools would just screw this up hopelessly. You go slow, you use hand tools, and it's not hard. You just have to be patient, and you occasionally have to throw things away and start over.
You did it perfect on this one.
Yeah, I think this one turned out very well. Very fortunate. Sandpaper, and I got it wrapped around the blade of a plane, which I use as a scraper, and I'm just trying to take that high spot down slightly. Only has to go down maybe 1/100 of an inch or less, and we should have a good fit right there. Let's check it and see if it's any better. Now is size the pieces before we glue them together. The purpose of sizing is to seal the wood so that it doesn't absorb glue from the interior of the joint and result in a dry joint. This should always be done immediately after, or as soon as possible after, resurfacing the pieces for the joining, because a fresh surface absorbs glue better than a weathered surface. Also, I've got a heating pad wrapped around the parts because a hot piece of maple will absorb the glue much better than a cold piece. So I've heated it, dip my finger in the glue, smear a little on, give it a nice even coating, not too thick. And the purpose of this again is just to make sure that the wood does not absorb glue from the interior of the joint. Okay, I put that one aside, and then I take a little bit and do the same thing to this. But what I'm going to do is grab that little bit of sandpaper and run it in there a little bit to roughen it up. Paint that glue in there, make sure that I coat all of it everywhere, right down to the point. I'm using a solution of glue that's a little bit thinner than what I would use for sinew backing so that it penetrates the wood better. Lower viscosity, better penetration into the wood. And I keep these parts warm because that aids in the absorption of the glue. So now I'm going to put this all back together inside the heating pad. Wrap it up again and let it sit for about an hour. And let that stuff absorb the glue. I'm going to take this out first though, because I don't want to accidentally glue that to the pieces. Make sure you got a nice coating on there. The wood absorbs the glue incredibly fast when it's hot. So I might just leave it like this and then lay something over the top of it to keep the heat in. It's important to keep this stuff warm. Joining these pieces, I'm going to work very fast. They've been heated, they've been sized, the sizing coat is dry. What I'm going to do now is clamp this into my table at just about the right angle so that I can glue this piece in, and I can force the two pieces together and clamp everything down tight. So I'm going to quick check this, check that the angle's fine, so I can force that in there and hold it in place. It's good. Now what I do is I put the glue on, working quick, put plenty of glue on. I'm going to end up splattering glue on everything, but you know, you can just clean everything up when you're done. Get a lot of glue in here because a lot's going to get squeezed out. I found that working with your fingers seems like it's a hell of a lot better than working with tools when you're in a big hurry. I'm just checking the joint to see if I see any spots where there isn't obviously glue between the two pieces, and if I see any places where the joint is apparently too thick, I put another clamp there. But you know, a little bit of black language and some panicky work, and we've got this thing put together pretty well. I'm pleased with it. Now it's just a question of coating the joints well, because as the glue dries it tends to contract, and the glue will get sucked into the joint by the material that's already in there. So I just want to make certain that as it gets sucked in, there's more on the outside to pull in after it. So we get a nice tight glue-filled joint. Of course, if you don't like it, if you don't think it worked out well, what you do is the very next day you take these clamps off, you put a little bit of stress on the piece, and if you hear creaking or cracking, you can always just pop that thing back out of there again, soak it in water, play a little bit of heat on it and take it out, sand it out, recut the joint, and redo the whole thing. All things considered, when you're going to take months to make a bow, taking a couple of extra hours to redo the joint doesn't really amount to a lot of extra effort. Just have to make sure that all these things are done the right way.
Now, whenever I've built composite bows, which is only a handful to date, I've never grooved. And Jeff states that about I believe it's 1/3 of original composite bows were probably grooved, which what that does is create more gluing surface contact to absorb all those stresses. And I could never figure out how it could be done. And after watching what Jeff's doing here, it's just so simple. So we'll just let Jeff explain to us in a minute exactly what he's got and what he's doing.
Okay, what I've got here is a guide that has a ledge on it that guides the tool. It has a trough that's slightly concave that the belly of the horn fits into. And I have a tool that's made out of, this particular one's made out of an old saw blade. It's got 12 teeth to the inch. And what I've done is grind those teeth down so that they're perfectly triangular, little right triangles, right angle triangles, 12 to the inch. And I've made a handle out of maple that fits into, and I can move from side to side. I bind the horn into this trough, and I decide which part is the straightest that I plan on keeping for the bow. And I slide this back and forth in the trough. And that's all there is to it. Once I get all the grooves started, and they're perfectly straight, I can take them out of the trough, I can bind it onto the workbench, and I can scrape with a hand scraper, which is made out of the rest of the blade of the saw. These two pieces together, this one to start, this one to finish, allows you to make these grooves almost perfectly straight. And 12 to the inch, perfectly straight grooves, triangular grooves, and there may be a 30th to maybe a 50th of an inch deep, at the very most maybe a 50th of an inch. This will double your surface area for gluing, or actually it increases it to 140% of what it would be if it were flat. It allows the horn to be bound onto the wood without any sideways slipping. It gives a real tight fit, and it's actually very easy to do. You could make a grooving tool with a machine shop, with a milling machine. Cost you quite a bit of money to do it on a computerized milling machine. Or you can do it by hand, spend a couple of hours cutting out the teeth, and get a job that the tolerances are to within a couple thousandths of an inch, which is more than sufficient for this job because the glue line is a couple thousandths of an inch. So to restart, I just make sure that the tool is in one of the tracks, and I cut.
Once a certain depth is reached, Jeff has turned his form over, tied the horn to the opposite side, and now he's able to exert more pressure. His grooves are deep enough to keep the teeth within. And you're going to take them down, what, to the full depth of the teeth that you have, Jeff?
Yeah, I just sight down the grooves and make certain that they're ground to a point so that they're not flat topped. And once I reach that, everywhere along the entire length, I figure I'm finished. You can see the straightness. There may be, if you look at it edge on, you may see a real slight wobble in one or two places. But if you hold a steel straight edge up along them and sight along the straight edge, you don't see any bends, any wiggles. They are dead on, perfectly straight. And therefore, you have to realize that your eye is able to discern differences down to thousandths of an inch easily. The glue line is going to be 5 to 6 thousandths of an inch thick. So you are well within the, if you do things this way, you're well within the tolerances of the glue line, and you're going to end up with a very good joint.
All right, you spend how much time? Now you've only spent, what, 2 hours, 2.5 hours on this?
Yeah, maybe closer to 3 because we started it earlier and ground away on it, but then that's 3 hours with a couple of breaks in between, sitting back to have a soda or a cup of coffee. This is about the 6th bow that I've done this way, so a little bit of experience has made it go faster. But you don't have to do things this way. You do not have to put these grooves in. The only reason why I'm doing it is because this particular style of bow that I'm building is a quote-unquote replica of a Middle Eastern style of bow that did have these grooves. And in fact, only Turkish and Korean and a couple of other isolated nations built bows by putting these grooves in. You can make the back of the wood, or rather the belly of the wood and the back of the horn perfectly flat and smooth and join them together, or you can cut them slightly concave, convex. And I have a grooving tool that is concave for the wood and convex for the horn with teeth cut into it that I would use to make a Turkish flight bow. So this particular operation you can regard as being optional, and it was not practiced by all the makers of these bows, but it does give you a very good joint with a lot of extra surface area, and the strength of a joint depends on the surface area of contact.
Okay, and then transferring this over to wood, it'd just be a piece of cake now, wouldn't it?
Oh yeah, the wood itself grooves much more readily because it's coarser grain, it's a softer material, the tool bites into it more deeply. I have had to sharpen the tool once or twice while I've been cutting this into the horn.
Now before he can cut grooves into the core to match the horn, what he's doing now is rasping down where the ear sticks out that he glued on. Got glued on yesterday. Now take note on the glue line of the splice. Almost appears as if it's one piece of wood. Jeff admits this is one of his better jobs. Why don't you explain a little bit, Jeff, about how you're getting that line started?
Well, what I've done is clamped a guide to the edge of the bow and put something underneath it to support it so that I can get the grooves started at least on the curved section. The flat section I can clamp into the guide the way I had done with the horn. But this curved section can be a little bit of a problem, so I use a slightly different method of just clamping a guide onto here and scraping the grooving tool along the guide to cut a series of guide cuts into the wood. And once they're a certain depth, say a quarter of the way down into the tooth, maybe a little more, I can take this metal strip off, just an old hacksaw blade, and then cut the grooves normally.
Okay, you can see the grooves now, how they match up. Nice and straight, parallel. This is what's going to give the glue joint a little bit of extra strength, increases the surface area, keeps the piece from slipping sideways when we bind it. The next thing for us to do is to gently steam the horn while it's clamped into place on the wood so that any little deviations will be brought to conformity. Then we size it twice, let it dry, heat it up, put the glue on, and bind it in place.
What you see here is the bond that we're looking for between wood, which is on the top, and the horn. And on the left has a sinew layer. This is a cross section of what we're building, what Jeff is building.
Just gently steam the horn side of the two pieces clamped together tightly with the grooves lined up. I'm steaming the horn side because it's more plastic. It's going to mold, the heat will cause it to mold and bend and conform a little bit better to the wood. If there were any slight deviations between the horn and the wood, say thousandths of an inch, that's all the horn has to compromise by. And I just do this for a few minutes. I usually use a little more vigorous steam than what you got, what's visible here, but I regard this as being essential, and this just makes the pieces fit together a little bit better.
What I'm going to do now is square up the sides of the wood and the horn so that they're flush together along the whole length of the bow. Both sides. I do this only for the purpose of making the gluing, the alignment of the two pieces with the glue on, go a little bit quicker because time is going to be very important there. This is not final shaping. That I do separately. I do it after the horn's attached. This is only to aid in lining up the two pieces for gluing because time is very, very important at that stage.
And you can see how close to fit the horn and the wood come, you know, where they come together. It's just perfect. The grooves have lined exactly. What's being done now is Jeff is resurfacing. Right now the core, he'll do the exact same thing with the horn, so that you have a completely free, sterile environment for the glue to stick to. Alright, Jeff is right now putting a sizing of hide glue. This is pretty liquid, right? Yeah.
Very liquid, yeah.
Right, very liquid hide glue on. In fact, it's so liquid he's painting it to size the horn and the core prior to bonding. Now these have both been preheated. He uses these electric heating pads and does it quite a while. When I have built mine, I've just heated them by the stove. Yeah, in fact, he has a bow heating by the stove right now that we're going to send you. The heated part absorbs the glue much better. And now these have to be dried completely prior to the actual bonding process.
Okay, here we go.
As Jeff has said, this is madhouse time. This is when he screams and goes crazy, folks. Things are falling all around. You may have to disregard his language. Things have to go fast at this point. The sized pieces are being glued, and then things will really get crazy. You watch the tools. We'll try to explain them later. Everything has to be perfect at this point. The bow, horn have to be kept warm. As things are put together, the grooves have to be lined up exactly. And then clamp. Now comes another hairy part. The word perfect used once.
Okay.
Success. Jerry's holding a vise-like clamp. Jeff is going to bind it. Tools of his own invention through trial and error. He's done this himself on 7 bows.
See, I'm bottomed out on my clamp.
Okay.
This is crucial. Jeff's got approximately 150 hours of work up to now just in what he's doing.
Out of that joint, getting a couple 100 pounds per square inch on it this way. It's extremely uniform pressure all the way across the surface of the whole piece. Clamps alone just cannot do it. This can buckle or anything. I'm probably just collapsing the very edge of that piece of horn, but I don't care. I don't care.
You're anchoring your tool in place, you say?
Yeah.
And now you'll steam it.
Now I'll steam it and correct it to see if it's twisted. It is twisted. But I just steam it and untwist it, and it'll be fine. It's not using glue. In other places it is, but God, it looks like a really good joint. It's joined real tight everywhere. I found where we did crack the very edge of the horn, but it's in a really insignificant place. And it's in a place that's going to be ground off eventually anyway. That kind of stuff happens because you put so much pressure on these things with that tool. Yeah, it looks good everywhere, John.
Well, that's why we did it. Now Jeff's getting steam out of that pot. What's this doing, Jeff?
Alright, just in case the glue gelled while we were binding it in place, I'm heating up the horn side because the horn's a good conductor of heat. And that will transmit the heat into the glue. The glue will re-liquefy and squeeze out of the joint. That way we make sure that we have a thin joint. We only want about 1/1000th of an inch glue line, a couple thousandths of an inch glue line. And so I'm just trying to gently heat up that horn side a little bit, just to make sure that if we had gelling, we correct for the mistake. Gives a better fit.
Okay, when we're sinewing, heat is pretty critical. Jeff has done them in the shower before, or in a bathroom with the shower running on hot. Jeff will explain this here pretty quick, but this is done right close to our wood stove, plenty warm. We've assembled all the pieces. This is really the final major step in building this bow. And Jeff's going to do this in 3 to 4 or 5 layers of sinew. You're watching the first one here. Jeff, you want to take a second and explain exactly what you're doing in this first layer and how you're going to apply the following ones, which we won't be showing.
Okay. What I'm doing is laying down first bundles of 3 or 4 long fibers over the midsection of each limb, the bending portion of the limb, and they extend up onto the handle section and onto the ear or the ridge. And I lay these on in sort of a brick pattern. They're staggered. The idea is to cover the wood uniformly with a uniform thickness, depth, cover all the wood. I'm laying them wet fibers soaked in glue. I've soaked the fibers themselves in water before saturating them with glue. I have the gluing surface itself is wetted with fresh glue. When I'm finished with the mid-limb section, I move on to the handle and the ear, and I lay down shorter bundles of fibers that overlap those that I put on the limbs themselves. That'll hold them in place, keep them from peeling up. A fiber, when it contracts, when it dries, when it shrinks, is going to shrink in proportion to its length. So if I were to lay long fibers over a bent section like here or here, they'll pull up when they dry. So I lay short fibers there. I make sure that everything is staggered so I don't have any seams or joints where the bow is going to bend appreciably. It'll break there then. And I make sure that I put a uniform coat on. This particular step in sinewing the bow is very crucial. This is going to make or break it. It's the sinew layer that gives the bow its structural integrity, its structural strength. And if this is goofed up, you got a weak bow that can break on you. If it's not done in a very symmetric, smooth way, the bow will have weak spots and strong spots and won't bend uniformly. So this is very important. You don't put it all on in big globs. That's the wrong way to do it. I mean, that's fine for little bows. This bow is going to be a flight bow. It might weigh 100-pound draw weight, and it might shoot an arrow a half mile someday. If I put all the sinew on in big globs, it's not going to shoot a half mile.
All right, you mentioned the bending portion of the limb. Explain that.
This section right here is the only part of this bow that will bend. Only that piece. And so that section has to have whole fibers laid over it with no seams in the bending portion. And so what I do is I retain my longest fibers to be laid down over that section.
so that I can do it with absolutely no seam. It's a nice continuous coating. This is the ridge, this is the handle. Those sections will be coated with shorter fibers, and those fibers are put on there just to build up thickness and to anchor the parts, the fibers that are laid down over the bending portion of the limb. Those are the working fibers. Now this is just the first coat. I'm laying these down in little bundles of 3 or 4 fibers, maybe more. When I do my final coat, what I'm going to do is tie the limbs of the bow together. After this layer shrinks, this limb will be bent inward to about here, to about that point.
Right.
And what I'm going to do next for the second layer is tie the 2 limbs of the bow together in that place, apply the second layer of sinew, and then the bow is going to reflex even further.
All right, you're starting with a certain reflex here, and you're going to end with a reflex basically what we had on the bow that we showed at the beginning.
Or much more. The limbs could cross. But at this point it might be inappropriate to put down a really large reflex by tying the limbs together, because the sinew will take a 4 to 5% strain. But if I tie the limbs together now, when I get to the point where I'm pulling this bow back, I might be putting in double that strain. And so those outer layers of fiber, the last layer that I lay down, will be doing more work than they're capable of doing, and they may blow on me. So I like to do it this way. I've sometimes started with a bow very nearly straight and sinewed it with this much reflex on the first layer, and the limbs have crossed on me. So I don't want to do much more, because I want a bow, not some broken stick that I hang on the wall.
Now the glue has to be kept warm in order to stay in liquid form, and so as you know, he's got hot water in the pan and glue in the cup, which keeps it in a liquid state. And if it starts to gel up at all or cool off, he'll have to reheat this all. You'll see the sinew laid out on paper towels which are damp. That's to keep them that way. You don't want dry sinew going into the glue and then going on the bow.
It won't shrink. As people do it that way, but the sinew will not reflex even a half as much as it will as if you soak that sinew in water before you lay it down.
Because it stretches as you put it on. Here's a good view of the, just a side view of the bow. Jeff has got 1 layer of sinew. The first one put on, he's explained to you how he put them on. But questions can arise, or might arise, it would to me anyhow, is the sequence of building that layer and additional layers onto that. You want to explain that, Jeff?
Okay. This first layer consists of long fibers in this section, shorter fibers overlapping the first layers laid here, shorter fibers overlapping those laid here and on the handle. Now the second layer that's going to go on top of this will be put on after this cures out. The 2 limb tips will have gotten much closer together when this dries. They'll be tied together a little bit with a string barely taut before the second layer is put on. Fresh glue will be smeared over the first layer of cured sinew. The second layer that goes on will again consist of long fibers over this section laid down first, but even longer fibers now, that overlap the pieces laid on the ends.
Now you mentioned curing out period. How, days, weeks, hours?
Depends on your climate. If you're in a very dry climate like Utah or Nevada, you might let it go for a week. I sometimes let it go for 2 weeks. I think a week is sufficient, pretty much no matter where you live.
So I've rushed when I've built mine.
No, this is a very dry climate. Days here. I live in Wisconsin. It's a wet climate.
Okay.
All right, and then again, for that second layer, I lay another course of shorter fibers here overlapping the long ends of the long fibers laid on this section. And I may begin to build up thickness with very short fibers, maybe 2 inches long, placed here to bulge out the handle, and placed over the ridge section to give it a triangular cross section, peaked here and sloping down gently to the sides of the bow
to the edge. Your second layer of sinew, you should also cover up any wood that you inadvertently left uncovered the first time. Now, allow that second layer to cure out. The bow will reflex even further. The limbs may come close to touching. Again, put a new, fresh, slightly taut string between the limbs. Smear a coat of glue on that second layer and lay down your third layer. The third layer is not laid down in bundles of 2 or 3 or 4 fibers. I lay down single fibers, one at a time, that cover, that overlap the ends and cover the entire surface of the bow from here to the other side, corresponding section on the other side, in a perfectly homogeneous, seamless layer. Because that's the layer of the bow that is going to do the most work, the
Now,
outer
what's the
layers.
diameter of that thread? Now, you can break sinew down to minuscule, 1/16th of an inch, smallest 1/32 of an inch.
Hair-like. Get it as fine as you can. Break it down into hairs. Here's a nice one laying right here.
That'll show good right there.
Okay. That's about the size that I lay them down. A little bit bigger than a human hair, like maybe like a horsehair. Horsehair is a good example.
Right.
It's about the thickness of hair from the mane of or tail of a horse. And now you allow that last coating to dry. If you want a more powerful bow, you can put a fourth coating on. But that last coating should be laid down with no seams, no butt joints. It should be homogeneous from end to end. Edges of the sinew slightly overlapping, the ends rather slightly overlapping. And you want that coating of sinew to be about 1/8 of an inch deep.
At what point do you come to the sides of the bow? I see some threads on the sides overlapping the horn.
I've already covered the sides. I usually cover the sides early, and again, if there's any shrinkage, I cover them again. I make certain that the sides are covered right down, overlapping very slightly onto the horn. And when I build up the top surface of the bow, I like my top surface perfectly flat. So I may lay an extra layer of sinew along the very edge of the working section to give me a flat top. That way I have a lot of fibers doing a lot of work on that outer layer.
Now Jeff is going to show us what he has come up with as being two, or the only two, safe methods to string and unstring this, all this power. He's got one which is a board, but this one he prefers because it's able to carry it and use it in the field. You want to explain it to us?
Okay, this consists of two forms. One I have lashed onto the bow to begin with, and they conform to the curvature of the belly of the bow. They've got a slightly concave top surface lined with leather and some holes with ropes, and these are lashed onto the limbs so that they can keep their curvature while you place your knee or something here on the bow, and then grab the two limbs and pull inward in a normal bracing motion and slip the string off. Then you can ease up on the limbs and take each limb off of the form separately, and you only have to worry about one limb at a time, because technically each one of these limbs is a separate bow.
Now it's only going to go back, it's not going back to its full reflex immediately, as you say, because it's been strung for quite some time, right?
Yeah, this bow has been strung since Thanksgiving time. It's now starting the second week in January. This bow has spent months strung in the past, so it will not retain its full reflex for a couple of days, and heat will help it do so. If you keep it warm for a couple of days, it'll retain its full reflex within, say, a week, under good conditions, being kept warm.
So you're just lashing both ends to the form to the limb, and what that does is it relaxes that limb, or bends it enough so that it relaxes the string and the string can be removed. All right.
And then the final extra push is provided by somebody who will unstring the bow in a normal motion and then slowly remove these two pieces. This is safe.
That's safe is what we're after.
This is the old Turkish way. The Chinese also used it. Very standard way of doing things, and they were very safety conscious.
Now we want to remind the viewers here that there's so much power in this bow. You go ahead to work there, Jeff.
Okay.
There's so much power in this bow that if something broke that string, if something went wrong, boy, it'd just take the top of your head right off. Extreme, extreme care must be taken.
Right.
Jerry slips the noose off. Jeffrey relaxes the bow. And that's what we have.
Now we take care of each limb separately.
Okay. It's critical that both ends of that form are lashed securely.
Okay, operation's done. Now in a couple hours this will regain its full reflex. Keep it warm.
Okay, here Jeff is on top. That's the shape of the bow prior to his stringing, what, 2 months ago, wasn't it?
Yeah, this bow has spent an enormous amount of time strung, and right now it's spent almost 2 months straight, strung and being shot, being pulled every day. We just got the string off of it. Right now I can actually see it gaining reflex. I can see the limbs moving upward as we speak. What I'm going to do now is just warm the limbs and keep them warm for a while, and after about a week of keeping it warm it will regain almost all of this curvature, probably 2/3 this much curvature again. It should reflex back into a nice shallow C shape, or maybe even a deep C shape. But the trick is to keep it warm while it does this, and it is time consuming. The warmer it's kept, the better, the quicker it will regain the reflex. I just warm it up with heating pads.
Alright, the other method Jeff has come up with for stringing and unstringing bows is board. What, pegboard? What do you call it? Stringing board?
Yeah, this is a stringing board, or you can call it a pegboard, or I guess some version of this was probably carried by armies in the Middle East back in what I refer to as the good old days, and people still use these in warfare. And what this does is provide a nice convenient platform for you to independently bend and peg down the limbs. And all you need to do is to make sure that everything is nice and strong. Because if this bow gets away from you, even on this board, you're going to be hurting. So what I do is progressively bend the limbs down into position. But again, first thing you do before you do this is you always heat the bow. We heated the limbs in front of the stove.
Well, you heat it also by rubbing with your palm briskly.
Yeah, you can rub with your palm in the field if you have to warm up the bow. You rub real vigorously.
The horn just needs to be warm when you're working it. Jeff prefers the forms for this process. He says it's much safer than what the board is because it can twist and get away from you.
Yeah, this might look like it's easy, but this is trickier than the other method. More things can go wrong. It's harder to do by yourself. It's actually harder to do by yourself. It's easier to adjust a bow when you have it on this form, though, because you can clamp things to the form to set the curvature of the limbs.
Note the loose rope to hold the handle. And the 90-degree bend in the hook to help prevent it from kicking out. The board itself is 3/4 inch plywood. And here the bow is braced enough or bent enough to be braced to put the string on, which it is now. And I think Jeff is going to give us just a little talk right now on the construction of the bowstring, since it's a bit different than what most of you will be familiar with.
Okay, this bowstring happens to be a 1,250-pound test. It's made by the endless loop method, where you take two pegs, specified distance apart, and wind string between the two of them, and then the ends are served to form a pair of loops. Then there are a pair of adjustable auxiliary loops that are held in here with double-ended bowline knots. Those knots are self-tightening, but they're very easy to take off and adjust when you release the tension in the knot. Everything is served, even the extra loops are served. Sometimes you can get by with using a sinew loop. That absorbs shock because it stretches a little bit. That was commonly used in Asia. This particular type of string occurs on Turkish bows. An actual bow line would be tied in the end of an ordinary bowstring on a Chinese bow, but again it would have a long loop on the bowline.
Why is a long loop? Let's show that.
The long loop is needed because if you did not have that long loop, it might be possible for the heel of this loop to slip over the shoulder of the bow. The sia kind of separates the two parts of the loop, the two pieces, and keeps that loop centered on the limb. So that's put there for stability. It's done for stability. This is a string bridge. It's just a piece of antler that's bound onto the bow. It's a little bit wider than the limb. It's a safety feature. It's on there to make certain that that string does not slip over the shoulder of the bow. That can happen. On Chinese bows, those string bridges are usually very large blocks of wood or ivory. These are just little bits of antler. One safety feature that I always put on bows is this strip of horn that's been set into the ear of the bow. That gives it a little bit of extra strength, especially if you've had to violate the grain in that piece of wood. There's also a binding of sinew a little bit closer to the limb than where the knock lies. That's to protect from splitting against the shock of the bowstring. I put a very thick band of sinew on there, but I think it's a smart feature. It's a safety feature. You can see that the bridge is a little bit wider than the limb. It's put on there with a rounded edge where it comes into contact with the bowstring knot to make certain that I don't cut the bowstring with the bridge.
Waterproofing. Everything we're doing, the glue, the sinew that's holding this bow together, if it got wet, well, you've actually soaked bows to take them apart. So you want to keep it dry, basically. Explain us a little bit of what's cooking there.
Well, there are a lot of different coverings that you can put on a bow to keep it dry. Very thin leather can be glued over the sinew of the bow, but a common Asian practice was to use the bark of trees, certain types of nearly waterproof bark. This bow has strips of paper birch glued onto it, and they all overlap slightly, and they cover all of the sinew right down, overlapping onto the belly and covering a little bit of the horn. The horn is polished black, and then you can lacquer or varnish the bow with something like a sandarac resin or copal or damar varnish to enhance the waterproofing. But you should keep in mind that when you glue this bark on the bow, the bark is nearly waterproof. Use as little water as you have to get the glue fluid, and allow the bow a long time to lose that water, because this will the bark will trap the water from the glue, and you don't want the bow to rot, so allow a long time for it to dry out.
Well, I know that I hear in the American Indian part people talk about using snakeskins a lot. You've used snakeskin on one anyhow.
Right.
Does it really help a lot?
I feel that it probably does help against incidental or accidental soakings. It may act as a barrier to mist, but if you really soak one of these bows, it will come apart on you.
Okay.
So it will help you out in an accident, but it's not something that's going to absolutely make your bow permanently waterproof.
Okay, well now we got the bow, which in your case that bow is, what, right at 100 pounds.
This bow shoots about 100 pounds at 27, 28 inches.
And now we don't want to just go shooting any old arrow out of that.
No, certainly not.
Explain a little here.
Okay. I have a pair of arrows here, and the most important difference between the arrows that you would shoot out of this bow and any old arrow is the nock preparation. You can see on the lighter colored arrow, the nock has a small horn insert. Okay, there's a horn insert set perpendicular to the nock. It goes in about a ½ inch or more. That's glued in place very tightly with hide glue. Then there's a binding of sinew. On the lighter colored arrow, that's a short binding. On the red arrow, that binding is almost 4 inches long. And this is a binding with extremely fine sinew wrapped very tight, soaked in glue, and the feathers are laid right over it. Now that is to protect that arrow from splitting under the impact of the string. You may notice that the knock is ground out a little bit farther too. It's a round tubular knock because these strings on these bows are very large diameter. They have to be. And so
Okay,
you don't
why
want
don't
your
you
knock splitting.
Twirl the light colored arrow around a little bit so they can see the knock on that. Yep. Yeah, because the amount of force of that string coming against that, it just blow that into pieces, and it drives through your arm.
Yes, it's very important to make a safe, strong knock for these bows.
For these arrows.
Yes.
You can see how that insert is set down completely into there. How far down does that insert go, Jeff?
On the light colored arrow it goes in about a ½ inch. On the red arrow it goes in almost a full inch. Well, you might not want a 100-pound bow, and so designing the bow with the correct thickness and width is going to be very important. The effectiveness of the width is that if you double the width, you will double the weight of the bow. If you double the thickness of the limb, you will make the weight of the bow go up by a factor of 8. So a very small increase in thickness is worth a very large increase in width. Now when you design your bow, you should make the ratio of the thickness of the sinew and wood and horn all about the same. Each should be about 1/3 of the thickness of the bow. I like to have a little more horn than sinew. Now I think you should probably shoot for an overall limb thickness of around 5/16 all the way up to 7/16. 7/16 is the thickness of the bow that we shot at 100 pounds. 5/16 will give you a bow of maybe 50 to 60 pounds. And that's if you make the limbs about 1 1/8 inch wide. 1 inch plus 1/8. And keep in mind that if you make the bow just slightly thicker, it's going to be a lot heavier. If you make it slightly wider, it will only be slightly heavier.
What about limb length?
Limb
And
length,
these measurements that you just gave, thickness-wise.
yeah, keep in mind that these bows only bend in a very short section of the limb. So the limb length that we're talking about here is maybe 22 inches from tip to the handle. Maybe 24 inches.
So if they were to make a longer bow, they could proportionally make it thicker?
I wouldn't make it thicker, I'd make it wider, because a slight increase in thickness makes a very heavy bow.
Right. Jeff, you want to go ahead and grab those tools and mention real quick that I'd commented throughout the tape often that Jeff had made this or invented this and whatnot. Well, he apparently hasn't done everything. Go ahead, Jeff.
Okay, a number of these tools are really of very ancient origin, and the only innovations that I've really made have been in redesigning a few and introducing a few more. This is something that I've been using to put bends in items, pieces of wood, and I should not say that I've invented this, but it's a useful little device, and I wouldn't be surprised if they've been around for a long time. The scraping tool, the handle, very standard, used in Turkey for centuries. The only things that I've really introduced that are new is a guide for scraping and grooving surfaces and a movable hand clamp that can be clamped on the tables. This is a useful device. Cotton rope in here that stretches. This is a useful device for you to make. I would suggest that you go ahead and make one of these things. Very, very handy. Other than that, all of the tools that we've used, for the most part, are ancient Turkish or Chinese tools. They've been around for a long, long time.
All right, now we've fortunate on the bow that you built here, there's one horn per limb. And one of the bows that we showed earlier had like 7 splices in it.
Right.
Why don't you explain a little about splicing the horn?
Okay. Mongolian bows in particular would have several pieces of horn in the limb, 4 pieces of goat horn spliced together. The proper way to splice the horn is by butting 2 pieces together, because the horn is under a purely compressional load. And if you overlap these, they can slip under compression. They'll just slip over one another. If you fishtail joint these things together, that's a lot of work for achieving a joint that's not going to be any better than simply butting them together. So the proper way to splice horn end to end is to square the pieces very carefully and butt them together, and when the bow reflexes, it may pull that butt joint apart very slightly. Then you should grind that joint out and put a small horn or ivory or bone spacer in there to distribute that compressive load between the two limbs.
What you're viewing here is a mistake not to make. It's an inversion of a bow. It was braced too low, and because of that, the string wrapped back around, the bow came back on itself. You can see where it's almost alive.
It inverted.
And
Did you see
it was because it was not braced high enough. This is an Egyptian angular bow.
I'm impressed. And scared. I wonder why. I don't mean to do it. You know, I think I know why. It's still not braced high enough.